I want to start today with a challenge for every single one of you watching. Most people think science is a collection of facts found in textbooks, static, unchanging, and settled. But real science happens in the dark, in the moments when the data refuses to make sense. Here is my challenge. Can you handle the uncertainty? Can you sit with the realization that we are currently watching an object from another star system, something that traveled for billions of years, completely ignore every rule our scientists have ever written? If you're the type of person who needs a neat, tidy ending, this story might frustrate you. But if you're ready to see what it looks like when the universe decides to rewrite its own script, then pay close attention. NASA's latest update on 3i Atlas just landed, and I can tell you right now, the one word everyone was hoping to see is nowhere to be found. We were all waiting for the all clear. We were waiting for the line that said the behavior was stabilizing, the activity was settling, and the comet was finally behaving like a normal, predictable outbound traveler. But that's not what happened. Buried under layers of technical jargon and dry data tables is a reality that is becoming impossible to ignore. 3i Atlas is not stabilizing. It is refusing to calm down. If you've been following this interstellar visitor with me, you know that we've been waiting for the epilogue of its story, but today's numbers suggest we aren't even close to the end. In fact, we might be right in the middle of a very intense second act. Usually, the day starts with routine checks. New images from ground-based telescopes, fresh brightness measurements from spacecraft cameras, and position data to refine its path. It's supposed to be a smooth curve. You plot a point, you confirm the model, and you move on. But when the teams laid today's data onto that curve, the model didn't just bend, it broke. In the world of cometary physics, there's a very simple script. As a comet moves past its closest point to the sun a moment, and we call perihelion, the show is supposed to wind down, the heat decreases, the gas production drops, the dust jets weaken, and the light curve starts a long, graceful slide towards zero. It becomes a quiet, frozen rock again, minding its own business as it drifts back into the dark. That's what happens to 99% of the comets we've ever observed. But 3i Atlas is currently throwing that script into the trash. Instead of following the predicted decline, the real-world data is sitting high. While the comet is technically fainter than it was at its absolute peak, it is still significantly brighter than it should be at this distance from the sun. It's almost as if someone grabbed the downward sloping line of the graph and refused to let it fall. This is our first major warning sign. If this were just leftover dust hanging around from its earlier flare-ups, the core of the comet would look blurry and indistinct, like fog slowly dissipating in the morning sun. But when the astronomers stacked today's high-resolution exposures, they saw something entirely different. The inner core isn't fuzzy at all. It's sharp, and wrapped around that core is a fresh, faint arc of material, a new shell that wasn't there just a few days ago. Think of this as a timestamp made of stardust. It's a signature of a very recent pulse of activity, a fresh explosion of gas and dust that occurred long after the comet was supposed to be going to sleep. This isn't old material drifting away. This is a living, breathing system that is still actively erupting even further out. The tail tells the same. Instead of a diffuse, spreading cloud of dying debris, the tail still has a defined spine, a narrow, bright lane running right down its center. This indicates a focused, high-pressure flow that is still being fed by active jets on the surface. In fact, on one side, today's images show the tail actually thickening again, as if a side fin of material has suddenly strengthened. This isn't the geometry of a system shutting down. It's a system being updated in real time by forces, and this is where the mystery gets truly deep. To understand how 3i Atlas is spinning, NASA monitors how its brightness rises and falls over the course of several hours. As the comet turns, different features of its surface face the sun. Some areas are highly active, blasting out gas, while others are quiet. This creates a rhythmic pattern of light, a heartbeat we can measure. For a stable comet, this heartbeat is like a Swiss watch, predictable and steady. You can set your clock by it, but when they overlay today's measurements on top of last week's best fit model, the peaks of the heartbeat had drifted. They didn't line up anymore. The main peak is arriving a little bit earlier in each cycle, meaning the comet is actually spun up. It's rotating faster now than it was just a few days ago. Even more interesting is that a secondary bump in the data, which used to be small and fuzzy, has suddenly grown sharp and consistent. is like a second heartbeat has suddenly announced itself. A second active region on the comet, which wasn't doing much before, has now become a major player in the comet's behavior. To make the math work, the team had to shorten the rotation period. The comet is speeding up. And it's doing so because the jets on its surface are acting like tiny rocket engines, pushing and twisting the nucleus as they blast material into space. This leads us to the most unsettling part of the latest updates, the orbital solution. Now, calculating where rock is going in space is usually straightforward. Gravity does most of the work. You factor in the pull of the sun and the tiny tugs from the planets, and you have a clear path. We've been doing this for centuries, but with a comet, you have to account for non-gravitational forces, the rocket-like thrust caused by venting gas. If 3I Atlas were stabilizing, those jets would be fading, and that thrust would be dropping towards zero. The orbit would start looking like a clean, simple, Newtonian path. But today's data shows that not only does the orbit still require a massive non-gravitational correction, but that correction is now pointing in a different direction than it was yesterday. Using yesterday's math to predict today's position resulted in a measurable error. The comet isn't where it was supposed to be. It has literally steered itself into a new position because the thrust from its vents has shifted. When you look at these three independent signals, the brightness that won't fade, the core structure that keeps erupting, and the orbit that keeps shifting, you realize they're all telling the exact same story. It isn't just one weird measurement or an error. In a single telescope, it is a consistent, verified pattern across multiple lines of evidence. And when you think about what's happening inside that nucleus, it actually makes a terrifying kind of sense. When 3I Atlas dove past our sun, it didn't just get a sunburn on its surface, it was hit with a massive wave of thermal energy that is now slowly migrating into its interior. Heat doesn't move through ice and rock instantly. It takes weeks or even months to reach the core. The surface material, the soft ices and loose dust responded first, giving us those early wild displays. But 3I Atlas isn't a simple snowball. It is a layered, complex body that formed around another star billions of years ago. It has spent an eternity in the freezing void of interstellar space, bombarded by cosmic rays and micrometeorites, developing a thick, protective crust. So deep inside that crust, there are pockets of vol. Each of these pockets has a different trigger temperature. As the heat wave from our sun continues to crawl deeper into the comet's heart, it is hitting these pockets one by one. And when it does, the ice doesn't just melt, it sublimates instantly into gas, creating enormous internal pressure. Physics doesn't care that the comet is now moving away from the sun. Once that internal pressure cooker reaches its limit, it has to vent. Every time one of these deep pockets erupts, three things happen. First, fresh material into the coma, keeping the brightness high and creating those new shells we see in the images. Second, these new jets apply torque to the nucleus, twisting its spin and changing the rotation period. And third, the total thrust on the comet shifts, forcing NASA to rewrite the orbital equations to figure out where the object is actually going. From the outside, it looks like an object fighting our models. From the inside, it's a body under unimaginable structural stress. Now, I want to be very clear about one thing. Does not mean fragmentation has started. We haven't seen a second core splitting away yet. There isn't a line of debris trailing behind it like breadcrumbs, and there hasn't been a sudden, catastrophic brightening that usually signals a total breakup. We aren't seeing the comet shatter, at least not yet. But we're also well past the point where we can call this a normal comet. A stable comet is predictable. Its behavior follows clean mathematical relationships that we verified on hundreds of other objects. But 3I Atlas is giving us something else entirely. It's giving us a rotation that creeps, activity that pulses in waves, and a self-driven push that refuses to diminish. This isn't theory or speculation. This is what the telescopes are reporting. This is reality. We are currently at a fork in the road, and we don't know which path 3I Atlas will take. On one path, the deeper layers finish venting over the next few weeks. The heat wave finally works its way through. The last pockets of gas are exhausted. The curves in the graph finally start to slide downward, and the comet becomes a quiet, fading chunk of ice drifting back into the interstellar void. Its moment in the spotlight ends, and it becomes a historical footnote. Interesting, but ultimately settled. But there is a second path. On this path, the pattern of late-stage pulses continues. The internal pressure keeps building in pockets that were never meant to contain it. The torque continues to twist the nucleus that has already been stretched. At some point, the internal structure of the comet reaches a breaking point. There's only so much stress a mixture of ice and rock can absorb before its structural integrity fails. The fractures that have been opening and closing might stay open. The cracks might propagate through the entire body. The spin could become unstable, and the nucleus could simply fail to hold itself together. If that happens, not stabilized becomes the backstory for one of the most dramatic events in the history of astronomy. We would be watching the final destruction of an interstellar traveler in real time. As of today, we don't know the ending. And what today's update tells us very clearly is that we are not at the quiet conclusion of this story. We haven't reached a resolution, and we haven't seen the final act. The heat is still moving, the vents are still firing, and the comet is still evolving. This object was born in a debris disk around a star we don't even have a name for. It survived billions of years in the absolute zero of the void, only to dive into our system and experience temperatures it hadn't felt since the dawn of time. Every day that so passes without stabilization is another day we get to learn what an interstellar visitor is truly made of. We are pushing this object to its absolute limits, and it is pushing back. The teams at NASA are checking the data multiple times a day now, watching every flicker in brightness and every tiny shift in the orbit. They are looking for the sign that tells us which of those two paths we are on. If you want to see whether tomorrow's update and finally shows the curves bending towards stability, or if 3i Atlas is about to rewrite the laws of physics once again, you need to stay tuned. This story isn't over, not even close. We are watching something that refuses to be tamed. Something that might still have its biggest surprise waiting for us in the dark. In astronomy, when nature refuses to behave, that's usually when we're about to learn the most. So that's when the textbooks get thrown out and new ones get written. So stay curious, keep your eyes on the data, and I'll see you in the next update as we follow 3i Atlas into the unknown. And we're in the middle of a cosmic mystery, and the final page hasn't been written yet.